async patterns. Most of the talk will be just a long introduction to them. Okay, so why talk about asynchronous programming? Let's start with how programming is done usually. So that would be server-side code. It looks like JS. Let's pretend it's not. Let's pretend it's like PHP or other things. So for instance, you would get an HTML template. That's a local file. Then some data of your own. You're querying a database. And maybe you're doing an HTTP request to get some open data from Wikidata. Then you're combining them, whatever, and you're combining the data in the HTML template to be ready to send that back to the client who asked that. The problem with that model is that usually that's the natural way to do it in PHP, in C, in a lot of languages. Each instruction is blocking, meaning that you do not query the database until the template is back. You do not ask data to Wikidata before the query is over. And that's problematic. So basically, we're on the left side for you, where queries are done sequentially. What we would love to do and what is in theory possible is to do non-blocking, and so ask for the template, the database, and the HTTP request to run, and answer back when they're ready, and then work with all the data that you've gathered. A previous speaker said that latency is a fact of life. Yes, it is. These are just rough numbers that you should remember. One that's interesting is the last one. At the speed of light, so you cannot go faster than that. Physics tell us. It still takes 8 milliseconds for a round trip between Bordeaux and Edinburgh. So I'm from Bordeaux, sorry. And that means that if you're doing an HTTP request and your server is doing nothing while it's waiting, there are maybe 8 million cycles that are being wasted. Your CPU could be doing some work like combining, pre-rendering maybe or whatever, but you're not doing anything. So that's pretty bad for performance overall. While I'm saying all that, I did not really come up with this idea. I really recommend this talk by Ryan Dahl, creator of Node.js. He's explaining the 4.4 slide way better than I could do, and what I had not tried Node.js, and I watched this video, and as soon as he said we're doing I/O wrong, we got messed up at some point. I don't know. I knew Node.js would be great for performance, yeah, because it doesn't wait for blocking I/O. I really recommend checking it out. That's the link. I'll post the slides later. And he says that asynchronous code, when you're calling a function and the function cannot return really quickly because it does not have the data it's supposed to return, then it should not look like the first line. It should be more. It should follow a pattern of like the second line, or I mean the second and third line, where you call a function and you give it a callback that's going to be called whenever the data is back. either from disk or from the database or from the network. Asynchronous code could look sequential with promises. That's a different talk, but that's in theory possible. Right now, I'm gonna just do a small diversion, talking about events. There are events everywhere. When I ask a colleague to do something, if I have a colleague and I rely on this person to do some work for me, I can still work myself. And we need some way, some sort of protocol so that he tells me when he's done, he or she, whatever. So that I don't get blocked, but I know I can pursue my task when it's done. It's like also like if I was late for my talk, you wouldn't be just you would not be blocking your brain. You would just be, I don't know, chatting with your neighbor. You would be chatting Twitter, but still listening on when I begin my talk, and as soon as I do, stop whatever you were doing to follow what I'm saying. So there are events. Anytime you have two separate entities, you need this for them to collaborate. You need this concept of events. But our programming model doesn't seem appropriate for that. I'm talking about the object-oriented model. What we're being taught at university, and I guess in the literature, is that an object? If I ask what's an object is, I guess I'm going to have this answer more or less. It's properties and methods, properties and methods. It's like I don't know, it's in our brains. And the problem is that properties and methods aren't enough to program things that run in parallel in time. This idea also that a program has a beginning and an end. If that's all what it is, then what happens if you want to know, if you want to react to a user clicking somewhere? That there is something that doesn't fit in our programming model. Also, there is this interesting thing that keeps coming over and over, is that people are reinventing events all over the place. In Java, they have the observable pattern. In JS, we have event targets, obviously, on the browser. And it's really interesting to see the trend. Initially, the DOM was just this idea of objects like properties and methods, and so you can append, you can remove a node. It's annoying, but you can. But at some point, people got the need to have events on the DOM. I'm only talking about the tree structure, not the user interaction. And that's how we got mutation observers. Likewise, for objects, you can add properties, you can remove, but at some point, people want to know when a value change and be able to react to that at a very low level. And so, yeah, events, we need them. They're part of how we want to program. Node.js, they could have chosen not to do events. That's probably one of the very first thing that was part of Node.js. And SQL has something called triggers. That's long story, but that's events as well. So basically, a trigger is that when a row is added to a table, you can have a trigger and trigger some behavior when that happens. That's an event. And I don't know. I don't know everything, but I assume that every language and framework and everything at some point needs some sort of event. So That's a little rant of my own. But I believe that we should start considering that APIs and objects in our programming model are more than properties and methods, and that events are a first class part of our APIs. I had this idea on my own, like, no, I mean, yeah, on my side of the world. And then I started looking around, and I noticed that, well, in Node.js, events are documented the same way they are documented as properties and methods. On MDM, the same. I don't know, yeah. Yeah, this one is cheating. I wrote that page. But the overall point is that events are part of the programming that we're doing, and it makes sense to have them alongside methods and attributes. For instance, I don't know, there is this, so that's the Web Radio API for Firefox OS. I don't know, for instance, the disabled event. I mean, you know that there is some interaction. It just doesn't pop up out of the blue. You know that your object is in some state when the disabled event pops up, happens, and etc. That's part of how we program. So yeah, events, they're part of our API. I hope you're convinced now. I'd like to talk about a little bit about something. Yeah, we're talking about the event loop, and when talking to people, I sometimes have the impression that it isn't really clear what it is exactly and what guarantees it provides. So I'd like to just do a couple of minutes on that. I've come up with this visualization, which I didn't come up. I did not invent it, but it's trying to represent what a JavaScript runtime is. So you have a stack. So for each function call, you have a new call stack frame with the local variable, etc. You have a heap with pretty much every single object in your environment, and you have a queue. This queue, so the message queue, is it's where the asynchronous magic happens. Basically, anytime a user clicks, and you have a click handler, a message is queued. And I don't know, whenever there is a set timeout fires, something is added to the queue. And what we call the event loop, we call that the event loop, I guess, because there is some code which is just a while loop, I guess, in C, and just which code is pretty much while there is an element in the queue, process the element. And the processing is nothing but calling a first function, and this first function maybe will call other functions or whatever. And when all of that is done, process the next message. That's the model we have. It differs. Who has done some C, some low-level programming, C, C++, with threads? Threads? I love threads. No, I don't. One of the reasons that makes JavaScript intuitive and very easy to start with is this idea that you have this model and the run to completion model, so very few people have wondered, like, what happens if I click twice somewhere, but the processing of the first click is not done? Is it like, I don't know, destroyed? Is the first click destroyed? Do the things run in parallel? No, actually that's not the case. A message is queued, and it's going to wait for the previous click to be handled. It's going to wait for the first click to be over. Yeah, and one thing that's interesting in this model is, for instance, for web workers, what happens is that you have twice this drawing, and basically through post message, the only thing you're doing is one runtime is queuing messages onto the other, and that's how web workers work. That's pretty much how forked processes work in Node.js as well. Okay, and once you've realized that events are part of your API, you're starting noticing patterns, and there is this one which, let's call it promises. When you have an object that's going to eventually fire a success or an error event, and at most only one of them, we're seeing this pattern everywhere. Like, I don't know, geolocation. You ask for the user its geolocation, and either it's going to be successful or not. That's not how the geolocation API is not based on that, but that could be really easy to make it a promise. And I don't know, there are a lot of them. HTTP requests, HTTP requests is a combination, but a speaker earlier suggested the idea that an HTTP request would be a stream that will only have one value, and I thought that was an interesting idea. I would call that a promise. But, and streams. What is a stream? It's nothing but an object that's going to fire data events or value events, call it however you want, but that's going to fire events regularly. The click stream is a really interesting one, and has this idea, because a lot of examples of streams are finite. But this one is infinite. You're going, it really is an infinite stream. You have no idea when the user is going to stop clicking. So, and HTTP is nothing but the combination of those two objects, of those two classes, if you want. You can see an HTTP request as a stream. Let's talk about the response. Where you have bits of data that are coming regularly, and you also have the promise behavior, where you can wait for either a success and you have the full data, or an error. So, yes, that's it for now. If you see other patterns, I'd be interested. I feel this idea that events are part of our APIs is not enough explored, and I wish it. I wish we had a discussion on that topic. Maybe not right now. Send me an email or tweet or whatever. But yeah, I think it's something we should keep in mind. So thank you.